I think Wayne. I think Wayne is coming. I assume.
Who?
Wayne Harrison.
Oh, yeah.
Heard my name? What was that?
Oh no, I was just saying I thought you were coming. I don't see anywhere, but anyway, that's okay.
My camera doesn't seem to want to work today. That's fine.
Oh, you're a fellow.
Oh, there you are. You were there momentarily.
Okay, there we are.
Who's recording?
Brian Clough is joining us tonight. By the way, Brian's the B.
That's I'm recording,
Brian,
Ken.
Okay.
Dave's trying to come back with another browser. Somebody have a radio playing in the background?
Hey, Peter, is the mouse the same way?
No, it's better. It's fixed. Okay, now move it again. No, it works.
So it's that plugin.
Yeah.
No, I installed the plugin. I'm using the Chrome plugin.
Yeah, it was a real mess, Dave. What ends up happening is everywhere your mouse
Just keep in mind, Peter, just keep in mind one thing. Last week, we were getting the same thing and the server crashed. So it may not be my computer. It may be the server.
Yeah, but it's fixed now, but it wasn't a minute ago.
Yeah.
Anyway, whatever. It's working now.
Hey, remember when you and I were chatting, it was doing it between you and I as well.
So what does the Jitsi plugin do, Dave?
It's just a plugin. When you got a little toolbar and you hit it, and it just opens up Meet, just like the web browser.
Yeah, I think it's just another Chrome instance, right? A process, a Chrome process that's dedicated to Jitsi. So maybe there's a conflict or something.
I guess the question is it worth bothering with?
I don't bother. I just have a link that I just click on and go to that up in the toolbar.
That's what I do. Yeah. Okay.
Yeah. All right.
So I can see you, Brian. You must have figured it out.
Yeah, I got it working through Linux and Chromium. Linux didn't like Chrome. It likes Chrome.
Okay.
Okay, let's get going. So welcome to our mid-April meeting. I don't think we have anybody new here. No, it doesn't look like it. So the first things.
Brian's new. Brian's new.
Where's Brian? Oh, hi, Brian.
Hello. Yeah, I'm new to this Jitsi business. So,
how would you like to introduce yourself and a little bit about your background?
Yeah, well, Brian Clough, VA3 BPC. I belong to the Mississauga Amateur Radio Club, and I was well, people say they were when they retired, but I am a radio technician. I work for Canadian Pacific Telecommunications on their microwave radio network for pretty much 35 years. Spent about 10 years up north of Toronto, up around, ran through Bancroft, Halliburton, and down towards Madoc and places like that. I did the test and turn up and maintenance of stretches of the mainline system across Canada. And yeah, I've been retired about 22 years now. So that was a while ago.
Well, welcome to our meeting.
Well, thank you.
That's it. Okay, first of all, the reading of the disclaimer. Please note that all our meetings are recorded and made available to the public for viewing on our YouTube channel. By participating in the meeting, it is understood that you have accepted these terms. So, on the agenda tonight, we got Dave. He's going to talk about milling PCB boards. Peter's going to do a quick demo, LT Spice, step directive, or the duplicate command. He's also going to have some recordings to share. And Eric is going to talk about the Hammond Radio Museum tour. And I might have some to share as well regarding the VCR. Okay, take it away, Dave.
Okay. Are you guys be able to see my screen now?
Not yet.
Not yet.
Okay, it's coming up, I think.
It's a blank screen at the moment.
Yeah.
Black. There you go.
There you go.
Good.
Okay.
Okay, that's funny.
Okay. So, I told Peter, I said to slot me in to do this presentation later date, because sometimes I think you guys are probably going to get bored of me talking. I drone on about all kinds of stuff. So, recently I got a CNC machine. Peter, twisted my rubbery arm, and I went out and I got the, what's it called, Peter? The Saint Smart 3015 or something like that.
The Saint Smart.
Yeah, and so we got that.
It's the Prover.
Yeah, and it's a small
3018.
Yeah, it's a small desk. Yeah, it's a small desktop CNC machine, and it does all kinds of things. You're seeing is a lot of people milling PCB boards on these. So I've been milling a lot of PCB boards, and it's not as, there's a lot to it, and it's not as easy or it's not as simple. Everyone made it. So I thought experience about the machine. I call it the good, the bad, and the ugly. So just, in summary, if you're going to take away, this is what you should take away today. So you're seeing a lot of people doing CNC machines. If you listen to Solder Smoke, you'll hear that Pete Giuliano talk about his most expensive CNC machine he got from his son, because he paid for his son's college education, and he got a CNC machine out of that. Can you guys hear me okay?
Oh, yeah.
Yep.
Yeah, no problem.
Okay, good. Okay, so right now today, it's fairly inexpensive to fabricate, get a PCB from a fabrication house. And a lot of them now, they'll even populate the parts as long as you put in, like, for example, DigiKey part numbers. They'll go and they'll populate the boards for you, and it's relatively inexpensive. So if you compare the cost of like a typical PCB fab house versus milling, the PCB fab house is much, much cheaper. You get 5 boards for the cost of about $12 Canadian. So the CNC mill all in, you're going to end up spending about $550 all in. So if you look at that, for that cost, you could do 45 PCB boards from a fab house. Like, for example, a JLC PCB, that's 45 boards. That's a lot, Now, the benefits of a CNC, take it as I see it. This is my perspective, looking at the world through my goggles, is number one, it's faster. So if you have to go to a fab house, you're going to probably be waiting 2+ weeks to get a board coming in, and that's with the cheapest shipping rate. You could get a fast turnaround time, but you're going to be ending up paying $40-50 to get 5 boards. So, and as if you're planning to use a CNC mill for milling metal or plastic or wood, then it makes sense to make that investment. Want rapid prototyping, CNC mills definitely a way to go. However, that doesn't negate doing Manhattan or dead bug. All those mechanisms are still the cheapest way to go, and they're probably a better way to go than a CNC mill. About today, I was just going to go over the process. As a lot of my talks, it's not a tutorial on the milling process. I'm just going to talk about the process. Then I'm going to talk about the limitations, and then I'm going to talk about what my recipe is to mill a board successfully, and then a bunch of miscellaneous stuff, which we're going to talk about. So, is my screen refresh coming up okay?
Yep.
That's fine. Yeah.
Okay, good. Okay, so basically, whether you're doing it for a fab house, you're generating a PCB for a fab house, or you're generating it for a mill, you have to use a package such as KiCad or dip trace. Now, if KiCad, I'm not going to go through how to generate a PCB or generate a schematic. Go back to Wayne's presentation he did a year or two ago. Very good presentation where he walks you through how to generate a schematic and a PCB. So go back to that and you'll see how to generate a schematic PCB. But the exact same use for generating and generating the Gerber files is the exact process you do. The exact same process, except when you generate the PCB, you have to set the clearances for how much you want between traces and all that stuff. The fab house is going to give you published clearances that you need to go and program into your PCB program. Mill, you can put in your own custom spacing depending on a bit, and we'll go through some of that in a subsequent slide. So once you get your Gerbers, create your Gerber file, then to the PCB fab house or used for the mill, you then have to use a program such as FlatCam, which takes that PCB Gerber file and it generates G-code. And G-code is what drives a CNC machine, or it drives a mill. Can you guys mute your mics, please? So FlatCam, generates that G-code. I've got a definition of what G-code is here. And that's just the instructions that tells it how, like, for example, G0's code tells it to move to a certain X and Y location and so forth. And 00 is another code, and it just sends all these codes, and FlatCam generates some geometry, and from that geometry, your milling parameters, how deep you want the bit to go, number of passes you want it to go. And it's doing something called isolation, the pads, upper traces. so that it generates the G code, and G code is telling it where to go and move. And it's giving it the sequence of steps. The passes, if you on this final passes that it's going to make. So once you've got your G code, then at that time you now need to send that G code to the mill. Okay, so at that point you take your PCB, you stick it to the mill, and I use double-sided tape. A lot of people use double-sided tape. Some people use clamps, and you clamp it down, and then you do something called a height map. So all this is done in an open source program called Candle. That's one milling program that takes that G code and sends it to the mill. There's lots of others. Candle's one of them. Candle's not a very good program. It's got some kind of issues with it, but it works for me for what I do. But it's pretty limited. Some of the other programs could do a lot more. But it basically takes that G code, and then you do what's called a height map, and it goes around, it probes the surface, and it shows you the height of the copper is, because that copper board is not perfectly flat. So, you know, the bit might plunge down to a certain depth, and that depth might be much lower and may even miss the board completely, or the board might be higher and it may plunge too deep into the board. So that's why you do a height map, and it adjusts how deep it's going to plunge that bit. And at that point, once you marry the G code and the height map together, you hit the start button and the mill starts. And here's a little example of it doing a height map. Now, what you can't see here is electrical connection. There's an alligator clip behind this bit. You can't see it, but you have to solder a piece of copper to the board and attach an alligator clip, and then you attach another alligator clip to this spindle, and it goes down, and once it hits the board, it makes electrical connection, and it knows that's the height. It knows how far it needs to plunge down to hit the surface. And there's a little sample of it milling. And you can see as it's milling, you're seeing the little debris it leaves, which is very, very. Now I'll explain what this green tape here, why I've got this green tape in the background in a moment. And then, you know, you drill holes. Could everyone please mute their microphone?
I think everybody is.
So, you know, I not only do I mill the boards, but I drill those for the various through-hole components. And here's the first board I milled, you know, and I did a test board. I did all kinds of different clearances. And so I drilled down, I milled down enough where I didn't remove a lot of FR4. And there was some areas where there was a little bit of extra copper left over. And that's probably because of a height map issue. And I'll explain how that was fixed. But you could see here, I've got traces down to 0.25 millimeter trace. And by default, that's the trace width for in KiCad. They mill at 0.25 millimeters. And you could see here's a 405 SMD, which is pretty small. I think that's too small to mill. And, you know, you got SOIC and 1206. 1206, perfectly doable. I do 1206 parts all the time, and it comes out perfectly fine. So here's a
Dave,
summary
how
of
long
my
does it take?
CNC.
Dave, how long does it take to
Sorry?
do that board? That one you showed?
Oh, I don't know. I typically I'll mill a board and it may take sometimes 6-8 hours. If I'm doing a complex board, a simple board may take 45 minutes. So it's still, you know, etching. If you look from end to end etching, if you do in 6 hours to go and mill a board, end to end etching, you know, it's probably less than that to go and etch it, probably an hour or two. So etching is still, you know, quicker and cheaper to go and do, but you got to worry about, you know, getting the toner down. So here's some settings I kind of use. Now, the key thing here is the errors I measured in the X, Y, and Z axis. Now, all I did was I gave it a G code for it to move 200 millimeters, and then I actually measured how much it moved, and it was off by 2 millimeters. So it's 2 millimeters to 200 millimeters, which is 0.01. Now, ideally, you should do this 10, 20, 50 times to get an average. And this back when I used to teach robotics, and I used to teach the kids about robotics, I would have the kids do that. They would move their robot, you know, 10, 12 times, and they would measure the error in the robot moving, say, a meter or half a meter. And they could calculate what the error is going to be. So I just did one run, which is, you know, I was lazy, but I should do more. But the error is about 0.1 millimeter in the x-axis, and it's about the same in the y-axis. Again, it's about 0.01, you know, 0.007. I'd round that up to 0.01. And the z-axis, I'll show you on another slide how I measured the error there. Same thing. So you're getting about 0.01 millimeter accuracy on all three axes. Now there's the bits you can get. I started out using a 30-degree V-bit, what's called a V-bit. I'll explain what that bit is in a moment. And it's a 0.1 millimeter 30-degree V-bit. And you have to know what the width is based on the depth you're going to plunge down, and I'll explain what that is in a moment. But this changes, and if you get this wrong, you will rip your board to crap. You have to know how deep that bit's going and how much material that V-bit's going to clear. And if you get that wrong, your board's going to look like crap. Okay, and so I started out doing 0.1 millimeter deep cuts, and it left gaps. And if you go back to this slide, that's what this slide here, because that was a 0.1 millimeter depth plunging down, and it left places. So based on the error in the z-axis, which is 0.01, I now plunge it to 0.11. And I do that extra one just to account for the error in the z-axis. And that seems to work fine. So typically I do 7 passes with a 40-degree overlap. I'll talk about that in a moment. And I run multiple jobs. So I'll run one job slow at a slow feed rate. And I got the definition of feed rate here. It's millimeters per minute. So it's 60 millimeters per minute. The head is going to move in the XY axis. And the Z is going to plunge down at 40 millimeters per minute. And at 40% overlap. And then I run a second job at a faster rate with 20% overlap and about 4 or 5 passes, and that seems to work fine. My spacing for my height map, I do a probe every 8 millimeters. And some of this will make sense when I talk later on a subsequent slide. So if you look at the height map, after doing a height map, you get this file here. And there's a bunch of numbers here for where I think the 0 axis is, and some other stuff where home is and all that stuff. And these numbers are the probes. So here's 3 probes in one direction. I can't remember if that's the X. That's probably the X direction. And then it's got 10 probes in the Y. So in all, you got 30 points here mapped. So what I did, I ran exact same height map 3 times. So here's from run 1, run 2, and run 3. Then I looked at the average error in all 3 columns, or the average difference between, so the difference between these two, between these two, between these one and map 2, map 2 and map 3, and map 1 and map 3, I calculated the difference between the column 1 numbers and the column 2 and blah, blah, blah. Then I took an average. And if you look at the error, regardless, it's coming out around 0.01 if you round up, right? So it's coming out to be about 0.01. That's where I got my Z accuracy. So
Hang on a
why
second,
is
Dave.
this tolerance important?
Dave, hang on a sec.
Yeah.
People have been putting up their hands. Do you want to ask? Do you want them to ask questions now, or wait till the end?
Yeah, let's wait until the end, because this is not long.
Okay.
Okay, let me just kind of blitz through these slides, and then we can have a nice long discussion at the end. Okay, the reason I'm saying this is you got to see the forest from the trees. If you focus on just numbers for the sake of numbers, you're not going to get the results you want. So you have to take things in order of a magnitude. You can't just look at numbers as a number. Okay, so one of the key things is the clearances. Okay, so when you're milling, you have to mill the spacing between the pads. You have to clean that. You have to isolate the pads. That's why they call it isolation routing. So you're going in and you're milling the material between these pads. So you got to have enough passes to go and mill that stuff between there. The bit is so small, it can't just mill it in one pass. It's got to go through a bunch of passes, and it's got to mill all that material away. So you got to isolate the pads, but now the traces as well. You have to make sure that you do a sufficient number of passes to get between the traces and remove all the copper between the traces. It's same thing, the depth. If you look at the copper, you look at a FR4 board, this is a double-sided board. You've got copper at the top, you've got this fiberglass in the middle, they call that FR4, I believe. And so that thickness of the copper depends on the weight of it. Here's a chart showing, the different weights at 1 or 1.5 ounce copper. The thickness of that copper is about 0.03 millimeters or 0.05 millimeters. It's around, it's around 0.05-ish, 3-ish, 5-ish millimeters. So when I mill down to 0.11 millimeters, I'm removing 0.07 millimeters of the FR4. Again, forest from the trees. 0.07 millimeters. Do you know how small that is? That is small. So I'm not plunging. I am removing very, very little of that FR4 at 0.01, even 0.02 or 0.12 or 0.13 millimeters. I'm still removing very small amount of that FR4. So, and the key thing to keep in mind as you're milling these traces, you need to know what the X and Y, Z axis is. It's still 0.01 millimeters, so you're not going to be able to mill anything smaller than that. Because if you try and mill something smaller than that, chances are there's going to be errors. Because the mill is not that accurate. So, V-bits. Sorry, you're going to have to know what math. You're going to have to understand math here. So you're going to have to understand trig here. So this is a V-bit. It's basically a V. See the V? It's a V-bit, and it's got an angle. They measured the angle across in terms of degrees. So this is like a 30-degree bit. So the angle from one side of the bit to the other side, the inside angle is 30 degrees. Now, if you zoom in at the tip, you might think it's a point, but it's not. It's got a cliff. It's got an edge at the point, and that's where the 0.1 comes in. So if you look at a bit, you'll see the bit will say 0.1 millimeters, 30-degree bit. That 0.1 is that distance there. That's very, very important. Okay, you need to understand what that width is. And if you get that wrong, then it's gonna your accuracy, your milling is gonna look like crap. Okay, so basically, think of it like the thickness of the metal. That's a limitation of the thickness of the metal you're using, the bit. So the reason we need to understand this stuff is when you plunge this bit, I've exaggerated here, the bit going below a surface. So let's pretend that's the copper, and where it says surface, that white line's the copper, and below that is the FR4. So, I'm exaggerating it here. So if you look at the depth of the cut, how far are you going to plunge that depth down is that deep. But as that bit is moving, it's clearing this distance away. And that distance is a function of your depth. So just because it's a 0.1 millimeter depth, it's not meaning it's going to move away 0.1 millimeters. Okay, it's going to move away more than that because you're plunging it down. And you have to know what that distance is. And that's where the trigonometry calculation comes in, right? So the way you do this is a very simple calculation. There's a hard way and there's the easy way. I'm going to show you the hard way. So if you take these are two right angle triangles, and if you separate the two right angle triangles and you say one triangle is 15 degrees, the other triangle is 15 degrees, you separate them and you say the thickness of my tip is 0.1 millimeters. So if I plunge it down a depth that deep, this plus the 0.1 plus that is going to be how much of that copper I'm going to mill away from the surface. So I should have used a different number. Saying I'm plunging it down a depth of 0.1 millimeters, but the thickness is 0.1 millimeters. Those two numbers are totally, for this, I just happen to pick the two numbers, same numbers. They don't have to be the same numbers. In actual fact, when I do my depth, I'm using 0.12 millimeters. But for this calculation, for some reason, I use 0.1. So anyway, so if you look at this 15 degrees here, we need to know this side. This side's 0.1. This side is just 0.1 millimeters times the tangent of 15 degrees, which comes out to this 0.026 number here. So that number is the same as that number. So if you add this distance, which is 0.026, plus 0.1, plus 0.026 again, it comes out 0.1536. Now, in FlatCam, they've got a V-shaped calculator where you put the tool tip diameter, you put the angle, you put the depth you're going to plunge it, and it tells you how much material it's going to remove. And sure enough, look, 0.1536, 0.1536. So that's how a V-bit works. Now, you got the concept of passes. So one pass with the V-bit, it's going to move away 0.1536 millimeters of material off of the surface. And that's for it to plunge down 0.1 millimeters. Now, with a 40% overlap, this next pass, you're going to overlap the previous pass 40%. So 60% is going to be cut new, which is, 60% of 0.1536 is 0.9215. So if you go to a third pass, the same thing again. You're now overlapping with the previous part, 40%, 60% cut. So 60%, 0.9, is being cut away new. And if you do that for n passes, you come up with a calculation. And for example, for 7 passes, you're going to mill away 0.7066 of material. So that's why you need to do multiple passes and you need to know how much overlap you're going to have, because this is going to tell you how much material you're going to move away with 7 passes. So come on today. Okay, so how does the CNC work? So here's where we're going to have to understand a little bit about bits and chips. And I'm not talking about Ponch and Baker here. So key thing, first thing about bits, the wrong bits. These bits that come with the unit, these V-shaped bits, they are not for PCBs. if you look at the SainSmart PCB chart, and I've kind of merged these together, here's the bits we typically get. These are the bits, and they specifically say they're not for PCBs. So, and I'll show you why you would want to use these bits and what I have to do to make these bits work. But if you're going to buy bits, you got to make sure you get the bits that specifically for milling PCBs. Okay, and this is what happens. Okay, so here's 3 runs I did with the same bit, same depth, same exact run. And as you look at it, you zoom in, you'll see each subsequent run, you'll see it just ripping the shit out of the copper. It's just ripping the crap out of the copper. And so, you know, by the 3rd bit, it just butchered the copper. So is that because of a cheap bit? Is it a wrong bit, a wrong setup? Is it the bit getting dull? What's going on? So eventually I had to chuck that bit out. And so this is where chip load and feed rate comes in, okay? So a chip is how much material your mill is going to remove. That's what's called your chip size. It's kind of like a chisel. You know, when you chisel a piece of wood, there's a piece of wood chip that flies off. That's the concept here. So chip load and feed rate. To calculate chip load, you need feed rate. And to calculate feed rate, you need chip load. This calculation drives me crazy. But typically, you get chip loads and feeds and speeds and all that stuff from CNC machines. Now, the bits we get, they're so cheap, they have none of this stuff published. So that's why you see a lot of people just doing trial and error. But the bottom line with these bits is if this bit gets too hot, it's going to dull. If the chip size is too big, the bit's going to dull. If the feed rate is too high, the bit's going to dull. If the chip size is too small and your feed rate is too slow, the bit's going to dull. The bottom line is your bit is going to dull. End of story. So how do you combat that? And I'll show you. Is what I do, you slow down the rate, you run a low rate, and you use lubrication. You use oil. And that saves your bits, and you get much, much better looking boards coming out. So here's an example. This that's what the green tape is down for, because this board has oil, and as it's milling, you got debris flying around. You've already seen this video. So that's being milled, and the board has got oil. And after it mills the board, it comes out really clear. And so this here was milled doing. It's not a pass, it's an actual run. So, because you got the concept of passes with overlaps, but these should be runs. This should not be a pass, this should be run. So you're doing a completely separate job. Okay, so I do at least 2 runs. So I run it one time, oil surface, I go 0.1 millimeters deep, and a feed rate of 50 millimeters, and a plunge rate of 30 millimeters, 7 passes, 40% overlap. That's why I do my first run. My second run, same depth, I go faster because the material is now cleared away. So my second run, I'm doing 5 passes at 25% overlap, and I'm just doing that to try and clear away any remnants left over. This is a cleaning pass. And fine material still left over, I'll do a third run, but I'll plunge the depth, the bit down to 0.12 millimeters as opposed to 0.1 millimeters, just to try and clear away the debris. And so here you can see, here it is, 3 runs, 20 degree, 2 runs first, same, exactly what I discussed, lots of oil. And you could see, look at that. There's a little bit of copper, remnant copper left over here, but it came out nice and clean, each run, no dulling. The bit doesn't dull. And the same thing with drilling holes. I do the same thing. I oil the surface. Here you could see the clip here. So remember I talked about a clip. You have to attach a clip to the copper. So when it's probing, it makes electrical connection. So that's what I do for drilling. I use the height map I use for isolation routing. Here's what I go. I'm not going through this. This is just I've documented this more so my own sanity. So if I have to go back, I know that what I did to generate the boards. Here's how I generated drilling. You know, I use different drills and how I set up the jobs. And so this is coming to the end of the presentation now. So here's some finished products. So here's a board I milled. You know, it's a little bit blurry in places, but you could see it's nice, clean surface, all the material. Those are 1206 SMD pads. You can see the holes being drilled. That's for a SMA connector there. And the SMA connector fits in that nicely. You can see nice tight drill holes. The only thing I find with these small pads, drilling holes, you need to clear away a little bit more clearance here because you'll get a solder bridge. Here's some more finished boards. This is the board held up to a light, so you could see the traces, how clean the traces. Some more boards. Here's a populated board here. You know, with all the parts in place, the toroids and FETs. That's a power amp. Here's another power amp there. And here's some just odds and ends of things, you know, how to set parameters. You know, one of the key things is that after every job you do, you have to zero it. You have to make sure the job goes back to 0, 0. That way, when you run a subsequent job, it starts from 0, 0. And you need to program in, there's a user command where you could program in where 0 is. So just in case you got to stop for the night and you got to come back to it, this causes the mill to move to right where 0, 0 is so it could start the job. And the key thing is there's a kill switch on the side here. See, I'm pointing to it. When you're zeroing it or you're moving it, make sure you got your finger in that kill switch, because sometimes it doesn't hit the end and it'll go off. And I've broken some of the limit switches because it just goes right to the edge and it breaks the limit switch. So, you know, in this case, it's supposed to 0, 0 here. It doesn't. And that's an issue with sometimes in power on, it just gets wonky and you got to reset it a couple of times. This is how you set the home position. This is just walking you through how you set the home position. Unless you've got a CNC machine, this probably won't make sense to you. Another thing is that you got to make sure you center the bit in the collet. If your bit is not centered, this is what ends up happening. You rip the shit out of the board. Yeah, I caught this too late and it just destroyed the board. Just going around and the board's totally useless. It just, because the bit had a little bit of a wobble, like maybe a 0.5 millimeter wobble in it, and it just ripped the board to crap. And this is just some G-code references here and default settings, and that's it. So at that, I will say end. And let me, how do I stop this? Oops, there it is.
Stop sharing.
So go ahead with the questions.
Go ahead, Pete.
I forgot what I was going to say, but question-wise, but I guess just a couple of comments at the beginning there, Dave. One of the things I like about having the milling machine is that when the idea strikes you on a Sunday afternoon, you can get a board done and get yourself going right away. And and that's what I think is unique. That's what I like about it. I don't have to worry about chemicals anymore with the etching. I don't mind that at all. And Dave, you're talking about the amount of time it takes to mill the board. Yes, it takes longer to mill the board than if you're going the chemical method. But by the same token, when you're etching a board, you're sitting there most of the time with it, babysitting it and sloshing it around and all that kind of stuff. The mill, you can fire it up, and once it's going, you can just leave it and do other things.
Yeah, but it's a matter of price. You know, you're paying $500-600 to get a mill. I'm getting the use out of the mill because I mill, like just this weekend, I was milling boards. So I mill boards all the time. So I'm getting my money's worth out of it.
For sure. And, you know, the other thing too, speaking of the expense, you know, as long as your boards are 100 millimeters by 100 millimeters or under, you got that cheap price.
Yeah.
And
guess what? And guess what, Peter? Most of the boards I mill are around that size.
And that's the other comment I was going to make. And it wasn't until Phoenix came about that we realized the difference in price.
Yeah.
And I agree with you with candle. It's not a whole lot, but I find it works and I know it. So whatever the limitations are, I don't know what they are because it does what I need to do.
Yeah, I meant not candle, flat cam. Sorry, I meant to say flat cam. Flat cam's got a lot of issues, and that program, it hangs my computer all the time.
I haven't had problems with flat cam in that regard, but there's not a whole heck of a lot of information out there on it, and it's a lot of trial and error. And so if anybody else is contemplating going and milling and stuff like that, you'll definitely want to talk to the Daves and the other Dave I see here tonight and myself or whatever, because there's a lot of headaches that you'll go through that we could probably help you negate that part of it. And I think
and part of it too, Peter, is that when I use flat cam, I've got about 4 or 5 isolation geometries, you know, and I've got like 6 or 7 Gerber files. So I'm really putting it to its paces. And each geometry's got different depths and rates and stuff. And so when I save that and I open it back up, it sometimes hangs because it's just got too much stuff in there to deal with, right?
And that's it for me. Thank you, Dave. I enjoyed that. And you're going too fast. I can make some notes, but I know where the information is now.
All right. So how long do you figure it took before you could successfully cut a board?
3 bits and
how many sheets of copper?
You know how many bits I broke just getting, because one of the key things, I've got a video that I didn't show. One of the key things you have to do before you start doing your height map is you got to take a voltometer and check the voltage between the tip and the copper and make sure you're seeing a voltage. Because if there's no voltage there and you tell it to 0, it's going to go right through that copper. It's going to go, the height map has got when it does a height map, it's got a fail safe. So if the bit goes where 0 is, if the bit goes a certain amount past 0, it just stops. That's a fail safe, and the program just stops. It says error. But when you 0 it to get where the top is, it'll just plunge and go right through. And I've smashed a bit and just destroyed a bit, and it just crumples the bit. And I'm surprised I didn't screw up the thread. And that's because I didn't have the probes, the electrical probes properly connected. So to answer your question, Ken, it took me several days. It took me maybe 3-4 days, you know, not contiguous, but over a week kind of thing, you know, spending maybe 2-3 hours a day, you know, playing around with it. So it's got a pretty significant learning curve.
Yeah. So I guess when you buy bits, you buy baker's dozen.
Yeah, I buy like now, because once I found out those bits are not rated for PCBs, and that's why I believe those bits were getting dull, because they're not rated for PCBs. Once I found out what the PCB bits are, I bought those. I haven't used them. I'm too lazy because I figured out how to use the cheaper bits. So I'm using them and they work well. Once I oil and I get slow the rates down, the bits, I've got one bit there, I've milled probably a dozen boards off of, and the bit's not getting dull. It's still going well.
Go ahead, Pete.
Yeah, I probably did about, I'm going to say over 20 little small sample milling processes, trying to figure out the depths and a lot of that, what Dave was going over, the 20, 30 degree. Actually, I cheated in the end. I was having trouble sorting out what that was all about. So then I just did a lot of trial and error and just said the bit is this. And then I played around with how deep I'm going. But Dave's method is a much better one, because what you're doing there is the correct way. The other thing that really hung me up, though, the worst of all, was in the candle program. When you hit, I forget exactly what the commands are right now, but you actually hit, you tell it to go and you expect it to mill, and the machine goes to that starting point and then it stops. So you go around to trying to get it start again. You hit every button that's available to you on the program, but nothing gets it going. But the button that you had to push and then get it to go is called pause. Well, who hits pause button to make the thing go?
I've never had that problem, Peter. As soon as I tell it, I can't remember. There's a thing that says go or plot or whatever. I hit that button and it just starts. I think it might be a setting that you have to set in your flat cam for the spindle speed. So maybe you've got the spindle speed because they like I don't know, because I set mine to 0. If you set it to, I know people set it to a certain speed, but I've seen for SaintSmart, a lot of people on YouTube say do set it to 0 and it goes to the maximum. Whatever the default is, you set in Candle.
Okay, I'll take a look at that, because like I said, I spent days before I finally got fed up and hit the pause button, and then it went.
Yeah, I never had that problem. I had the problem where the head just goes to the other side of the board, and it gets all confused. And I've broken limit switches, and since then I've ordered a dozen limit switches. I got a bag full of limit switches because I figure I'm going to be breaking a ton of limit switches.
Yeah.
Yeah, so I guess when you buy bits, you buy limit switches too.
Yeah.
Well, I've never broken a limit switch, so I don't know what Dave's doing.
Yeah,
I've broken bits because I've forgotten to put the clamp on the bit for when I was doing the map. And the problem is my computer, I'm facing this way and the milling machine's back this way. So I'm going back and forth, and sometimes I forget to put the little clip on. And then when you hit the button go, you have enough time to react and go back and catch it before you break your bit.
That's why, Peter, I said you always put your finger on that emergency stop button. As soon as you hit go, you run over and you put your hand on that emergency stop button, because if it looks like it's going wonky, hit it, restart it, because it's gonna break something.
In the end, for me, with all the headaches and all the trials and tribulations to get through to it, to be able to do a board, it was well worth it, in my opinion.
Yeah.
Okay, anybody else? Questions, comment? No. Okay, I guess we're done. That was great, Dave. Thank you. Pete, you want to take over?
Sure. I was just going to do just a little quickie here on with LT Spice.
There you go.
Okay. Just a very quick demo here. I just wanted to. This really only is just to show what you can do to do the same thing but a different way of doing it, and it's only really it applies to maybe a very simple simulation. But in this case here, you're going to run using the step parameter, and you're going to use the list command, because you're going to you want to do two specific values, 10 ohms and 10 k ohms in this particular case here. So when you run it, and then you plot it, you can see the two runs, the 10K and the 10 ohm running. You can see the difference. And that's probably the most common way that you're going to go about doing that. But there is another way that you can get the same results. If you take this particular same thing, but instead of running the step command, I'll just make a little bit of room here. Yeah, maybe you can't remember the how to write out a step command, that kind of thing, or for whatever reason just decide to go this route. You could use the duplicate function. So you select duplicate, and you duplicate your schematic. Now here, when you do that, if you're using labels for nodes, you're going to want to change them because you can't have two nodes with the same value or the same ident. And in the case here, your V2, V1, all your numbers for your capacitors and resistors, they all change automatically when you do the duplicate command. So we'll change this one to 10K to suit as what we did with the step command. And now when you run it, you got the same results. I'll just get rid of the phase. And there's the same results. So you can get the two different ways to get the same results. And like I say, most of the time you probably use the step command, but then again, maybe you might forget or whatever, and you'll use the duplicate because it suits. Maybe another reason why you'd use it is because you're going to go in and quickly change a value of a capacitor, and you don't want to write out another step command and change the variable, that kind of thing. Now, that's all I really wanted to show on that one. Just another way of doing the same thing. But while I was doing this, I noticed, now maybe somebody here has the answer. I never really see here on this directive here. In this case, it's you right click it and this window will open up. I'm using a decade sweep. And when I was messing around with this, I just changed for linear just to catch the difference because I've never really got my head around what they're after with these different types of sweeps. And if you look in here, you've got octave, decade, linear, and list. So I switched to the linear, and then I ran it. And look what it does. So to get around that, I realized then that it's the number, like this here is your number of points, and that's the secret to get around it. It's just add make a larger number of points there, and you will correct the problem. But, and there it goes, it's back to roughly about the same as what you got here. But I still don't really quite understand what they're after here with the type of sweep, unless they're just calling it that, and then and depending on what you select is the number of points that you put in the thing. I don't know, but does anybody have an idea really what's going on there between the type of sweeps?
No idea.
Okay. Anyway, that's all I wanted.
Peter
Yeah.
has to do with the doubling period. How much it doubles? A decade is base 10. It doubles like base 10. And I think octave is a different doubling period. It's in music. What's an octave in music?
Well, yeah, I know what it is. Yeah.
That's more of a music thing. The decade, I think it's a 10 log 10 thing,
So it looks like really the difference between, so as you go through, so it really doesn't matter what you select, but you got to make sure you got the number of points selected correctly.
Yeah, it's the doubling period, how often it doubles. A decade doubles differently than an octave.
Okay. Okay, a little bit there, Dave, or Ken, sorry.
You got something else to share there, Pete?
Yeah.
Oh, okay.
Yeah, sure. Just have to find it now. So as you probably most of you are aware, that Dave and I have been working on before COVID, the Dueling 612, which became the Phoenix project. So the other day there, I was just kind of buttoning up the prototype board that I used for the receiver, and I thought I'd just give it another kick at the can, just listening to it, and I decided just to make some recordings, a couple of recordings of it in the receive mode. And then I'll get started on doing the build. Incidentally, Dave, by the way, some parts showed up in the mail today, so hopefully I'll get started on that populating that board. Okay, so where's my notes here? This shouldn't be difficult, and I can't find them. Oh, here it is. So the first soundtrack I'm going to play. They're only about 10 seconds long, something like that. It's a CW signal, and it's an S3, S4 level. And this is, like I say, the Phoenix receiver board. Oh, I know what I should do. And there's the test setup. The Phoenix receiver circuit's there, and this is the... Well, who needed that part? And that's the audio amplifier. Actually, to Dave's point about talking about the trace sizes that he mills, I don't like 0.25 or very small ones on prototyping boards, because just as I just showed you there, I touched the capacitor and I popped it off the trace because the traces are too small. Okay, this one, like I said, CW S3 to S4 signal. Were you able to hear that?
Yeah.
Okay.
What band was that, Peter?
40 meters.
Wow. And you don't have that much noise. You must have a good antenna. Or no noise.
I was using my OCF.
Wow. That's pretty, that noise floor is pretty low.
Yeah. Oh yeah, it's not too bad here. If Drew was here, he would have a different opinion. But anyway, Drew just lives down the street, just not that far from me, and the noise level at his house is quite bad. Anyway, the next one here is another CW signal, and this one's S4 to S5. Okay, next one is about an S6 signal, and it's sideband, lower sideband. Again, 40 meters.
From Mariah Town, there's a small little park there, unfenced, and it's out of the way. Hardly anybody knows about it, even there's got people who live around there. But it's just a little municipal day park, and it's right beside the river. It's right beside the shipping camp.
And the last one, sideband as well, and this one's a little bit stronger signal, S6, S7. I think there might be some QSB in this one. I can't remember.
Turn the display light off and do whatever you can, to try to idle it down, but you can only take it so far unless you went in and turned the bias down. And then maybe if you got it down to say, I don't know, maybe.
Okay. So there we have the Phoenix.
Yeah, it's kind of interesting, Peter. You're getting right at the end of that last one, you got some CW coming in. Now, I don't know how far away that was, but it was making its way through the crystal filter.
Yeah, the selectivity is going to be an interesting topic for this, I think. I think if I was going to redo this stuff, Dave, I think I'd go to a 5 crystal filter for sure. But and the other thing, I'm going to have to pay a little bit more attention to the crystal filter as well, just in the design of it, because I think I can improve the sideband quality a little bit by messing around with that filter. I found it a little bit interesting to try and tune the signal in properly, because I think the ripple I got in my filter is doing something as well. But anyway, it was it was nice. It was good to get, I got a good couple of good signals to try, and so far so good.
But Peter, that's not bad for a couple of SA612s and a crystal filter and a mic, right? And a amplifier. That's pretty good, isn't it?
I think so, especially with the amplifiers and traces are ripped up on it and jumpers are all over it, and who knows what I've introduced there. But you know, and do I come up with a circuit maybe going forward that I can adjust the tone of it a little bit just to pick it up a little bit? So that's working on that in the back of my mind as well too at some point.
Okay, so we got any questions, guys, or any comments? Yeah, go ahead.
Had to unmute there. Have you got any AGC on that receiver yet?
No.
Okay.
No. If there's a version Phoenix 1.2 or it's version 2.0, then there'll be a lot of different things I think you'd take an approach there. But got to get through the first version, right, Dave?
Anybody else? Okay.
You know, sometimes I think you go through these. I mean, Dave could probably talk more of that considering all the trouble you had with the power amplifier. But, you know, you kind of get yourself on a train of thought. You get some specs going, and then you do it. And you just keep going. You got to put the stake in the ground at some point. Otherwise, you'll never get it done.
What I'd like to put in this, it's some kind of distortion detection mechanism, where, as Dave was saying, some kind of AGC, but it's based on distortion. So as soon as you're getting some kind of distortion, it would detect it and it would back off the gain, especially if you're on transmit, because you want purity. So if you're going to be overdriving the crap out of the finals and you're going to have all kind of spurious garbage, it'd be nice to somehow detect that and back off the gain.
Mm-hmm.
So that's kind of what I'm thinking. It's something like that, an AGC, but have it based not just on your ear, or, you know, have it based on some kind of distortion. So it can detect the distortion. And I've got a couple ideas how to detect distortion.
Okay. Well, that'll be interesting for sure, Dave. I have not, one thing I didn't have time to find was like a really strong signal, and then just see how it behaved with a really strong signal and see how much I can back off. Because the front end, the LT1253 op amp, basically it's on pretty much 99% or full gain. And a couple of times I've backed off on it a little bit, but not really a whole lot. But then again, I haven't come across like an S9 plus signal. Not that I've tried that hard, but it probably I should, just to see how it behaves.
Yeah, and Peter, that's one of the problems with those SA612s is distortion. If you feed in a signal that's too high, you get I think it's called the IP3. You know, you get compression and you get distortion. So I think that's one of the problems with those SA612s is that if you got a signal too hot coming in, you get a whole bunch of distortion. And that's why you'll see a lot of the older designs with NE602s, there's a pot to back off the gain, and that it's for that reason.
Mm-hmm. Well, I think the gain, I think the pot for I'm using for the gain on that 1253 will be on the front panel of the rig.
Okay, anybody else? Okay, very good, Pete. Thank you.
Hey.
Who's up next? Oh, Eric, you ready to go?
Oh, by the way, Ken, I just posted a definition of octave and decade in the chat window.
Oh, okay. Go ahead, fellow Gister.
Who is our fellow Jitster? Jitster.
Gister, you're muted. Go ahead, Eric.
Yeah. Okay. So let me get first my video back on here. Center myself a little bit. Okay. So last Wednesday, April the 12th, Wayne NWH and Michael TKI and myself were three visitors to the Hammond Museum of Radio in Guelph. So let's share the screen here. I want to tab anyway. Okay, hopefully everybody can see that.
Yeah, you're good.
Yep. Okay, so yeah, it was, but we spent about 2 or 3 hours at the museum, and no, this is not the museum. This is about 65 years ago, what the museum looked like. I don't know if there was more to it than that, but that's from 1960. The museum itself was started by founder Fred Hammond back in about 1928 or so, 1929, when he was 16 years old. So I think he got licensed in 1929, but yeah, he was 16, started his collection, early radio and wireless artifacts. So, but his first public display wasn't until this collection in 1960. He had a home in Guelph, and he had a little building at the rear of his home, and that was his ham station and his collection. So until that time, I guess for the 30 years, this is pretty much what it looked like. And this table of tubes is pretty much the same that exists in the current museum. So according to the curator of the museum, he was always interested in all things radio and all things wireless, especially. So him and several members of his family, I think he had about 4 or 5 brothers or so, started the Hammond Manufacturing Company in the early 70s. Transformers or their core business. They've branched out a bit into other things, and you'll see their nameplates on equipment at Hamfests and other. I recognized the logo immediately when I saw it. I know I'd seen it somewhere before, but anyway, so they built a new plant in the early 70s in Guelph and upscaled the museum to 4,000 square feet. He actually just had the area dedicated or set aside for it, and then in I think about 1982 is when the official Hammond Museum of Radio opened. So he died in 1999. Just before that, though, they moved to a new and larger facility at what's called the Hammond Power Solutions, a second plant. And that's where the home exists today, 24 years later. So hundreds of receivers and transmitters there. And let me see if I can quickly flip to, okay, so sorry about the small picture size here, but this was just lifted from their website. Unfortunately, I didn't get a really good overview of what the entire museum looks like from a perspective, but this is not bad. That's showing sort of the front half of the museum, or not front half, but the front, I don't know, 20% of it, something like that. But they have things dating right from the Spark era up until solid state HRO 500 nationals, and even newer. In their shack, there is actually a operating amateur radio station, which you'll see some pictures later. But so we both, Wayne, Michael, and I took pictures at the museum, and both Wayne and Michael, if you'd like to jump in and add your 2 cents into anything in this slideshow here, please do. It is apparently, I think, Canada's and possibly North America's largest museum of wireless history. So it's a bit of a treasure, and I didn't know it existed until a few years ago. So both Michael and Wayne had been there previously to the museum, so they were veterans. But anyway, that's basically it. About 70% of it is Fred Hammond's. The balance of it is all donations. And that's, I think, how the museum is. it keeps acquiring things. It's got enough critical mass that people know that if they've got old equipment, that's where it goes. So he was actually a Hall of Famer, amateur Hall of Famer. Not sure when he was. He was just a couple of years before he died. Actually, I have a note here. So anyway, let's see where. Go right back to the start here. So, Michael, you took this picture, I believe. Do you remember what? I don't even recall seeing this particular one. Do you remember anything about it?
Yeah, I saw this somewhere, and I took a picture. I have no idea what it is. It looks like, to me, it looks like one of the dials must be the tuning dial, and the other one's probably the volume. And yeah, I guess you really can't tell, but I just took it just because it looked interesting. The sort of cylinder on the bottom. Well, there you go. One of them's volume, and the other's the frequency. That's right. And on the bottom, I can see now there's sort of grooves in that. I didn't notice that before. There's this piece of string hanging off it, so I don't know what it is. It just looks like it's been made from a toilet paper roll almost. I don't know, but it looks kind of interesting anyway. This could be used to replace your toilet roll holder in your bathroom. I guess. I don't know.
Exactly.
The antenna coils up there. Roll up your antenna.
Yeah. Sorry, say again, Ken?
What it is. That's what it is. It's a toilet roll holder.
Yeah, the toilet roll becomes the antenna.
Yeah, and that's
I don't know. Anyway,
no joking. That's probably what that is.
That string has probably got a tag on it too.
Well, that's just identifying it for the collection. But no, yeah, you're right. I never even saw this one. But wow, there's an innovation.
That's for the addicted DXer.
Yes. And you can see, it looks like above the Futura name, it looks like that's a speaker grill there with a little hole, so you can
in there.
I guess. Yeah, I don't know. Yeah.
Wait a sec. Was this in the bathroom? That looks like a sink. That looks like a paper.
I think
paper
it
towel
was actually. I think it actually
was.
It actually. Now that I think about it, it actually was in the bathroom. I saw it. That's where I saw it.
That's why I didn't see it, because I never
know.
used the can there. So all right.
Anyway, so that's my contribution. It's the only picture I took, but there it is. Anyway,
in the bathroom. Very good. Okay. Well,
What a beauty of a picture it was, Michael.
Say again, sorry.
No,
he said
what a picture it was.
Yeah.
That's funny. So I guess you almost got that out under your trench coat, did you? That's why you're in the bathroom.
Yeah.
Nice. All right. So yeah, I took this one. This was kind of interesting. Everybody knows about these crystal radios on the Quaker Oat tin deal, right? What was new to me was the fact that it was an actual campaign by the Quaker Oats company. I didn't know that. I thought that was just a convenient form factor that everybody started to use. But at some point, that became popular enough that, like I said, 250,000 of these things were produced, or I think it was 270,000 by when all was said and done. But so how cool is that? So that was my one of my new facts for the day. So they had that there, which was an actual operating model. You couldn't operate anything that was in the museum other than when the stations were active. There's pictures of that coming up. But Mr. Fessenden grew up just north of where the museum is in Fergus. So they had quite a bit of literature and information on him there for the taking. So Reginald Fessenden, there we go. These were telegraph operated positions, the cigarette cases there, pipe tobacco cans were used. They would ding them in specific spots to change the note that was being played, so that when there was a bank of 15, 20 operators, they could tell who's receiving the transmission by the tone that would vibrate when the telegraph actuator was triggered. So that was kind of neat. Much like, I suppose, modern day grocery tills, where you have a whole bank of them and they each have a different tone so that the cashiers can tell who's doing the beep. So there's kind of the same vantage point from that earlier picture that was taken by me, but these are kind of unique. I thought Sonos was being unique and innovative, coming up with speaker lamp combinations, but no, back from the, I think, 50s and 60s, there were a number of manufacturers that made radios built into your furniture, your bedroom or living room furniture. So that was kind of interesting. You can see in the back left corner there the tube collector, the tube table, I guess we'll call it, much the same as it was back in the 1960s. So there was a complete number 19 set that some of you may recognize, and a little blurb about it, and there it is. So that's a rather fascinating piece of Russian history there, made by Canada for the Russians. So manufactured. There's a book that actually just came out, I think, a year or two ago, that aligns well with a lot of the offerings at the museum by a Canadian as well. This is the one of the two banks of radios in the station. I guess this is BJ, who I'm not sure who that is. Fred himself was VE3HC. So this is, like I said, it's the actual shack that you can operate from. There are local clubs that do use this from time to time. There is the other side, or the other wall, I guess you could say, of the shack. So well appointed, lots of modern radios in there, amplifiers and everything else associated with that, SWR meters, and etc. So that definitely gets use. Was not in use when we were there, but at other times apparently it is available. So that's the rear of one of those cabinets, all relatively easy to access for plugging and unplugging and making connections. So well designed little room, QSL cards, Wufong certificate that was issued to V3GJ. So little thing. Oh, this is a transoceanic Zenith receiver that caught my eye. Kind of a vintage piece that fortunately slipped through my grips at a local antique store several years ago. Lots of these Bakelite and other types of not novelty, but I guess these were actual radios. Novelties. There were lots of novelty radios as well, like the toilet paper roll holder version. But all kinds of. And what was the other?
These are Catalin.
Catalin, right, yes. So those are the two types of plastics that they had cases for, and just walls and walls of this stuff. So all receivers mostly. And there's our tube table up a little bit closer. Every manner of tube, and there's Michael immortalized in the back upper left corner there, in the mirror, I guess, mirrored surface.
Yeah.
There's our Bakelites, I think.
No, these are Catalin too.
That's right. Yeah. No, because that was an interesting little fact as well. Every batch had a slightly different hue to it because the pigmentation was totally up to the person who was operating the molding machine at the time. So that's why you never really have two that looked quite the same when they were, I guess, anything other than black. So, in fact, picture there. And I think that might be pretty much the end of our show. There's just our last picture. Again, a set designed to be used inside of a tank with the very large knobs, brightly colored knobs, so that the operator could use it with gloves on. See it, I guess, in dim lighting conditions, could tell which knob they were operating for setting different frequencies and oscillators, etc. So yeah, quite a fascinating collection. Like I said, we spent about 2 or 3 hours there, and it was well worth our time. The curator, Nori, was very enthusiastic and enjoyed her, her time. She, that you can tell that's her passion, is talking it up and showing off things. And yeah, so that was our visit. Worth a trip if you're ever out Guelph Way. She's happy to even show it to one or two people. You have to set it up in advance, but it's mission by donation. So, did I see a hand? I think I see a hand up there. Somebody had a question?
Yeah, no. So I just looked up the call sign. It's registered to Hammond Museum of Radio, care of Robert Frederick Hammond.
That would be the HC?
Yeah, the BJ, V3 BJ.
Oh, BJ. Okay. All right. So I guess HC is still directly registered to himself as a silent key. So, okay.
Seems to me I get cards. I do the 2-liter VE3 Kiyosabrio cards, incoming cards, and I have a bunch of HC cards from, I'm not sure when from, but I did have some for a while there. Anyway, I'm going to send them on to Nori. I'm pretty sure I got some, but I've got BJ's. I'll also send those on to her.
Oh, very good. All right, I'm going to close that, and I think you're back. Peter, you were sharing that, are you?
Yeah, just another version of the toilet radio that.
Holy cow!
Yeah, sometimes you have to turn the volume up.
That's pretty good.
Someone must have a patent on it.
Yeah. Anyway,
I don't know if I'd want to touch those knobs myself.
They're on eBay. Hey, they're on eBay if you're so inclined.
Eric's going shopping.
Nice. My finger is above the buy button. Buy now. Buy it now. Anyway, all right. Well, thank you for your attention. And if there are no other questions, that's that.
Did you see the spark gap transmitter while you were there?
We did. I asked if we could turn it on, but she said no. They haven't run it for about 2 decades or so, apparently. So.
My first visit to that museum, Fred was still alive, and he gave us the tour. And he said he used to fire it up for tours, but he says he no longer does it because he upset his fellow industrialists around the neighborhood.
Right.
If I remember correctly, when we went, the club went years ago, and they actually turned it on.
Yes, he said they used to.
One of the last times, I guess.
Yeah, he was quite the gentleman, Fred. When we showed up, when we showed up, he had a plate of sandwiches and everything out there for us to have while we were touring around. Really good host.
Yeah.
Very good, Eric. Thank you.
Yeah.
And
right.
Michael.
Yeah.
And Wayne.
Thanks.
And Wayne, yeah. Cool.
Were you the only 3 guys there, by the way, Eric?
Yeah, it was just the 3 of us. Yep. Hassan was potential, but he wasn't able to make it. So. Okay, back to you, Ken.
All right. I got a little something to share. I don't know if this is going to work or not. I had posted previously a little recording of the DCR. There was a request to compare it to an actual radio. So let me share. Come on. Come on, stay up. Share entire screen. Come on, do it. No, I gotta do. No, it won't let me share.
Is the window what you want to share? That window has to be open in order to share it.
Yeah, it is. Oh, here we go. So I got a little recording, just short recording. So I'm going to do, I captured a recording of a QSO going on 40. And then the second part of the QSO will be the same QSO on the DCR. So if this doesn't work, I can post it on the groups.
No audio.
You can hear the audio, Ken?
What was that?
You can hear the audio?
Yeah.
Oh, we can't.
Oh, I didn't think this would work.
We're not hearing it at all. Yeah.
I
don't know. I didn't think this would work.
I'm not sure how you pipe it from my audio. All I did was it's an external microphone that's into my camera that picked up the speakers.
Okay, I don't have an external microphone for it. You know what? I'll just post it. The results are very comparable. Mm-hmm. Actually, I think the DCR was probably a little bit quieter with the noise. But I'll post it up on the group there. And I think it's like 20 seconds or something like that. Okay.
Then we post it up on the YouTube channel and then put the link in the groups IO.
Yeah, we could do that too, but we got to set up a format.
Oh, okay. All right.
So I'll just share it on the groups IO,
okay.
And then later down the road we can delete attachments.
Okay.
So I think that's pretty much it. Does anybody have anything they want to talk about or have any questions about anything? Oh, I thought I heard somebody.
When will be our that direct conversion build taking place?
We don't know yet. The guys are concentrating on FDIM right now, so we got to do a second version of the board. Okay. And right now, I'm just playing with the KRP Labs bandpass filter to use on it. Go ahead, Dave.
Yeah, I was gonna, Wayne, if you've got the transistor tracer close by, do you want to just flash it up? Wayne
Actually,
was
I
able
do. One sec.
to build the version 1 transistor tracer, and he did an excellent job. I think he's going to give Frank a run for his money.
There you go.
It's got it mounted on a nice little board.
Very nice.
Does that look good?
Very nice. Very nice.
Yeah.
Nice.
I figured if Dave's going to take this, you want to put some lipstick on it first. So I bet it won't. Yeah, it works really well.
Wayne, it looks like a challenge, Wayne. You're raising the bar.
It was very easy to go together. It's a good kit as is.
He's being nice.
I
think Wayne, the hardware. Yeah. I think the hardware was easy, Wayne. I think you struggled a little bit to get the calibration software done, right?
Very nice, Al.
Yeah, it's coming back. You were challenging my eyesight with the surface mount devices, especially the Zener diodes, but we got them in. So I still have to do the defluxing and the visual, and then a smoke test. But the parts came in early this week, and I got it together this week. So hopefully it'll work. I see, Wayne, yours works. So knock on wood that I don't let the magic smoke out. But looking forward to it.
And if you want, Al, when you're ready to get the software going and get that stuff, because Wayne, I learned a lot from looking at Wayne's pain. So I think I might be able to save you a lot of your whatever's there's left on your head. You won't pull it out.
Could someone post?
Guys, we can joke about this because we're all thinning, right?
Could someone post the pictures of that? The PCB.
It's do you want the PCB, the picture of it assembled, or you want?
Yeah, the assembled one, just to see. Yeah.
Okay.
In our group. Yeah.
Yeah, because if you want to see the actual schematic PCB, you could just go to my GitHub page and everything's there. All the
Okay.
code, everything's there.
Okay. I'll check.
But it doesn't have a picture, an actual picture of the PCB, right?
Okay.
Okay, very good. Anybody else have anything to share or have questions, comments? Okay. There was some talk between emails regarding presentations. We were supposed to bring up something at the meeting here about presentations.
I can't remember exactly what I thought it was something else, but I can't remember what it was. So, but on the topic of presentations, we could certainly use some, and maybe it might be nice if we got. Not that there's anything wrong with the old blood, but you know, I'm sure others are building something or doing things on their benches that would be of interest to everybody. So, you know, keep it in mind. And, you know, they don't have to be long. They can be just like little short ones. Maybe not as short as my LT Spice demo tonight, but you know, they're all okay, stuff like that. Or, you know, another thing that'd be good too, or instead of a presentation, maybe show and tell us, you know, that kind of thing. So,
yeah, that'd be interesting. I think the other emails that were going through was about the SOAREX website, keywords.
oh, okay. I did talk to Peter about that. Keywords, hidden keywords, don't go that route. The Googles of the world have clued in on those things, and it penalizes you. So, if you're looking to do something with keywords, you put it right into your verbiage that you have on your website to begin with. There is a bit of there is a web page. It's basically just a placeholder with just some information while we kind of work a few things, try to get things sorted as to what we want to do with it. The address is soarexca.wordpress.com. SOAREX was already taken, so we threw in CA to identify it. But it's not quite 100% ready to go, but we're getting there.
SOAREX,
SOAREXCA.
SOAREXCA.com, is that what you said?
No, SOAREXCA.wordpress.com.
Oh, got it. Okay, thanks.
Sorry. Wait a minute. Let me.
Yeah, just stick in the chat.
Yeah, you're correct. SOAREXCA.wordpress.com. Comes right up.
Yeah. So right now, it's just kind of, say, working on a banner for the moment at the moment and trying out a few different things. Peter gave me some ideas to check out for some more for a picture on the banner. I think I found something. But anyway, if you have any ideas or suggestions, let me know. And I'll pass them on to Peter. We're all pretty flexible as to what we want. We're not even 100% sure what we want. We're just hoping that we get an information placeholder kind of thing up there in time for 4 days in May.
Yeah, cool. All right. Anybody else? Is anything? I guess that's it. Well, guess we'll call it a night now. And when's the next meeting? That's
well, the next meeting will be
May 3rd, a Wednesday.
Yeah, May 3rd. And then we have the one that's on the 17th. Now, the 17th, there's going to be a whole slew of us away, you know, with Dayton.
Okay. You know, we can post something up on the group there, see how many people are going to attend. If there's only going to be like 2 or 3, then, you know.
I think that are regularly attend these meetings. There's going to be 1, 2, 3, 4. I think there's 4 of us, 5 of us that are regularly attend that are going.
Yeah. I'd say we just postpone 17th.
Yeah.
Peter, you said
what was that, Dave?
I said, Peter, on Wednesday night, you said you wanted to go to the meet and greet at the Holiday Inn.
Yeah.
So if we go there, there's no way we're going to be able to attend that meeting.
No, I understand that. Yeah, that's what I was saying. I figured that we would not be attending the homebrew meeting on the 17th. So that leaves regular attendees probably in the neighborhood of about 8 that would be available to probably join in that night. So question is, do you have a meeting and just do a round table, or do we just forego it?
We could live stream from the bar.
Well, if it's your data plan we're using, I'm okay with that.
No, but Peter, we should put it to everyone else. If other people want to meet and chat and talk about something else, they shouldn't cancel a meeting just because we're not going to.
Yeah, I mean, my gut feel is to have the meeting and go ahead with it, if for no other reason than consistency. Now, the only thing is there is no presentation scheduled for the 17th as of yet, so it would be maybe a bit of an open house kind of thing. I don't know, but I mean, there's a few guys here that are not going down the Dayton this year. What do you guys think, Michael?
Well, I'd be happy just to defer personally. On this one.
Yeah, we can wait till June. I'm happy with that.
I would concur. Yeah.
Okay, well, then
I have one suggestion.
Yeah,
something different, but yeah, about our website. Maybe we can put a tagline or a slogan: SOAREX, homebrewers soaring high.
Yeah, there's some more verbiage that we want to put in there, Cherry. It's like I say, it's not a complete yet, but we're getting there. But if you got ideas, it's probably best to put them in an email to me, and that way I don't lose track of it.
Yeah, sure.
Yeah, it's just in the making right now.
That's right. Hey, Bob or Dwayne, are you guys going to 4 days in May this year?
No, I've still. I don't think so. I'm going to be down in Hilton Head. So.
Okay, and you spent all your money at Hamcation anyways, didn't you?
Yeah, I sure as heck did. But please, while you guys are there, would somebody go and take their cell phone and do a real slow and steady walkthrough and let us see what's at all the tables?
Yeah.
Okay, that would really help the group.
Okay.
And also don't forget to do that during vendors night so we can see what we weren't able to buy.
Actually, speaking of 4 days in May and stuff like that, too, we're going to do a club table, but have we given any thought, Dave or Eric, about how we're going to set it up? Or should we take it offline?
Yeah, we'll chat about it, but yeah, I guess.
I mean, when we were under the park umbrella, we had those park banners.
Right, and we had all the park buildathon projects too, right? So I suppose we're just gonna have to bring, all the works in progress, right? Don't think it necessarily has to be a complete. The projects don't have to be complete that we're showing off. We can show it as, what we've done in the
yeah, for sure.
We've existed.
Yeah.
You can also show the park stuff too. It's our park.
Yeah, that's fine. Yeah.
We're all developers of those projects.
Yeah.
Yeah. But yeah, no, we'll talk afterwards.
Okay. So I think that's about it. Unless somebody else has something to say.
Peter, are you still in Florida?
No, I had to come back to my shack. I was getting bored. I was lonely.
Okay, all right. Shack envy.
No, we've been back for a while.
Okay.
There's talk now that I'm going to be down there for about 2 months next year. So
Yeah,
it looks like all of February and March or something like
if
that.
you were driving up, you would be passing near my house. So
See what next year brings.
okay.
Next year it's going to be Orlando and not Tampa.
Okay. That'll be nice.
Yeah, he's gonna rent a semi and just take his entire shack with him.
No, my sister-in-law and brother-in-law are moving to Orlando from Tampa. So that's why. Anyway.
Yeah, but for 2 months, boy, you're gonna get bored.
I couldn't stay there for 2 months with them. 1 month.
Anyways, gents, I think that's it. So I bid everybody a good night, and we'll see you next month on, what do they say? The 3rd for our AF Mixer.
Okay,
So
great.
good night, gentlemen.
Thanks.
See you guys.
Thanks, Ken.
Guys.
Good night.
Thank you.
Yeah, you too, guys.
Hey, Howard, how you doing?